Yes, in this video we want to be looking at addition and subtraction in modular arithmetic. Now let's look at how simple it is. Modular arithmetic addition is similar to our normal addition, just some little differences. Let's look at the solution. Now number 1, we have 6 plus 12 mod 4. We can do this in 2 ways. But let me use the first way. Normally, if you're adding 6 plus 12, the result will be 18. So just write 18 mod 4. But if you look at 18, is 18 in mod 4? The answer is no, because 4 make use of numbers from 0 to 3. 0, 1, 2, 3. So we have to reduce 18 to number in mod 4. How do we do that? We have to divide 18 by 4, just like I used to explain. That's 4 times 4 plus 2 mod 4. That's 4 times 4, 16 plus 2, 18. Now, we don't need this multiplication part. We only need the addition part. So the result is 2 mod 4. Now, check this out. The answer is 2. Now, the difference between normal addition, if it is normal addition, the result is just 18. But if it is modular arithmetic, the answer is 2 due to some manipulations that we did. You can see that is why this addition is not a normal addition, and we have put circle on top of it, circle on it, so that it will indicate that this is clock addition. This is modular addition. It goes around like a clock. After reaching a particular value, it starts all over again. Then it has started all over again to reach 2. So that is modular arithmetic. Then another way to go about this is to first reduce this to mod 4 and reduce this to mod 4 and add. Let's go about that. This is how we go. Let's look at method 2. Method 2, for the same question, we can have 6 plus 12 mod 4. Method 2 for this is by reducing this and reducing this. So if we want to reduce this will give us 4, or let me say here, 1 times 4 plus 2 plus 1 times 4 plus 2 is 6. Then this is 3 times 4 plus 0 mod 4. Now, this is another way of writing 12. We don't need the multiplication part, we only need the addition part. So I will just say that, let me pick 2 here, plus, then the residue part is 0 here, then mod 4. We can now add this together. That's 2 plus 0 is still equal to 2. This is still equal to 2 mod 4. You can see that we have the same result. You can follow the same pattern to do number 2. It's by adding the same thing together or by following this pattern. So I will go to number 3. I will jump this number 2. We have done this, I have done this. Let's go and do this by yourself. And let's go to number 3. The number 3 question is saying that, number 3 question, we have 12 minus 5 mod 6. First, this is subtraction question. We have to subtract normally first. What is 12 minus 5? That's 7 mod 6. Ask yourself this question. Is 7 in mod 6? The answer is no. We have to reduce it to something that will be in mod 6. So by following the pattern that I taught in our previous video, you will say that this is 1 times 6 plus 1 is the same thing as 7 mod 6. That is, you will write your 7 as a multiple of 6. Write your 7 as a multiple of 6 by dividing that 7 divided by 6. 1 to number 1 all over 6. So that's 1 times 6 plus 1. That's what I wrote here. Then the equivalent answer will be 1 mod 6. That's the final answer. You can see that this is different from our normal subtraction. The normal subtraction answer is 7. How come we are getting 1? This is to show that this subtraction is not normal. It's modular subtraction. And that's why we circle the minus. Then for the last one, you can as well follow the second method. by first reducing these to mode 6 and these to mode 6, you will see, okay, let me use the second method. 12 minus 5 mode 6. Now let's break 12 down to mode 6. That will be 2 times 6 plus 0 minus 5 is already in mode 6. We don't need to do anything to that because mode 6 makes use of numbers from 0 to 5. So 5 is already there, no need. So that's minus 5 mode 6. Now the end result here, let's go for 0 and go for 5. That's 0 minus 5 mode 6. Now 0 minus 5 normally is minus 5. That's minus 5 mode 6. Then we still have to, minus 5 is not in mode 6. You still have to reduce it to something that will be in mode 6. We have to reduce it to something that will be in mode 6. So let's write the multiples of 6. 6 times 1, 6. 6 times 2, 12. 6 times 3, 18. And so on. Out of these multiples, which one is close to 5? 6 is close to 5. Let's write this as minus 6. Take it as minus 6. Minus 6 plus what will give me 5? Plus 1 mode 6. So instead of wasting my time, my answer will just be 1. The answer will just be 1 mode 6, which is the same as the answer that we got in the previous method. So you can see, let's go to the last question, which is number 4. Number 4 question is saying that 5 minus 20 mode 5 minus 20 mode 11. First thing, let's go normally. 5 minus 11 will give me minus 15 mode 11. So what do? We have to write the multiples of 11. 11 times 1, 11. 11 times 2, 22. 11 times 3, 33. Out of all of these, the closest one that is slightly bigger than 11, that's 22. Let's write, the one that is slightly closer to 15 is 22. Let's write it as minus 22. Minus 22 plus what will give me minus 15? That's minus 22 plus 7 mode 11. So the answer will just be 11 because this is the same thing as minus 2 times 11 plus 7 mode 11. Now we don't need the multiplication part, we only need the residue. That means the answer will be 7 mode 11. And that is our final answer. You can see how modular arithmetic is easy. Thank you for viewing this. God bless you.